Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this April 2026 lecture series, we are going to discuss about ground force measurements in measurement of pressure and blood flow. What is this ground force measurement? Actually, our problem is, a real world biomedical problem is, around 50 million plus people are affected with gait abnormalities worldwide and 684K annual fall related deaths, 8.6 million athletes requiring analysis. Here, the impact, if not solved, delayed diagnosis, poor rehabilitation, increased injuries, and suboptimal performance. Here, we need accurate force measurement, which is equal to better patient outcomes. See, the limitations of existing method, which involves subjective assessment, only 60% reliability, just 60%, and inconsistent data, 20 to 30% variability, lack of metrics, limited access. Here the clinical challenges are stroke gait assessment, rehabilitation monitoring, and early detection. Here, see the gap analysis, current versus required capabilities. Here, the elements are assessment reliability, data consistency, real-time capability, portability, and system integration. Here in this graph, red indicates current state and the green is our required state. See, ground force measurement, the force exerted by the ground on a body in contact with it. Here the application is fundamental in biomechanics for analyzing human movement and locomotion, which involves Newton's third law. For every action, there is an equal and opposite reaction. Body to ground, action force, ground to body, reaction force. See, here ground reaction force components, which involves vertical force Fz, anterior posterior Fy, and center of pressure COP. Here the definition is point of GRF application, and here the trajectory is heel to toe during stance. The purpose is it reveals balance control. See, force plate systems, the working principle is four corner transducers which measures GRF. It calculates Fx, Fy, Fz and moments. It determines center of pressure location. System types involves floor mounted, walkaway and treadmill. See the diagram, applied force, a top plate, load cell and ground reaction force. Signal flow architecture involves a transducer's force sensing system, and we have our transducer's output is fed into signal conditioning. Signal conditioning unit acts as amplifier as well as filter. Third one is our ADC part, which converts analog into digital. And finally, computer for analysis. Here the output is ground reaction force vectors Fx, Fy, Fz plus center of pressure COP. See the piezoelectric sensor technology. The working principle is mechanical stress is converted into electrical charge. Here the crystal deformation produces voltage signal. Here reversible is voltage to mechanical deformation. And the construction part, we have piezoelectric crystals, quartz are ceramic, electrode layers, we have charge collection layers, housing, we have protective layer with the help of metal casing, and preload mechanism, bidirectional measurement. See the piezoelectric force sensor. The next one is strain gauge load cell technology. Here the working principle is force into metal body deformation, strain. Here the gauge resistance del R, which is equal to R0 multiplied with GF multiplied with epsilon. Here the Wheatstone bridge, which gives voltage output, R output. Construction involves metal body, aluminum or steel geometry, and strain gauges, foil patterns bonded, Wheatstone bridge, 4 gauge configuration and protection, waterproof sealing. See the piezoelectric sensor, strain gauge sensor. Piezoelectric sensor, same both we have force input. Here we have piezoelectric material. There we have strain gauge sensor. Piezoelectric material. Here we have elastic element. Same thing for piezoelectric sensor, we have charge output, and strain gauge sensor we have voltage output. This is the measurement system architecture. Here the signal flow involves force sensors, signal conditioning and filtering. Then ADC2 processing, displays and storage output. See the clinical applications of our system. We have main thing is gait analysis, balance assessment and orthopedics. See, I've included student activity for 5 minutes, think, pair, share, role play, and as well as we have group discussion. Here the topic focuses on clinical applications and sensor technology in ground force measurement systems. See, here I've included some assessment questions from Gait as well as industry. Summary part, we have GRF components, systems, challenges, sensors and applications. The main thing is applications which involves clinical, sports as well as research. References. Thank you.